All right, we're looking at problem solving with combinations. This is section 2.3, so we're getting into actually working on problems with your combinations now that might involve a little more detail, such as cases. We had cases, remember with permutations, we had to use that indirect method, finding all the ways that we didn't want and subtracting it. We're going to apply the same idea here, along with some of the fundamental counting principle ideas. So if we look at example 1 from page 48, we have a delegation of 3 people that we want to make from 4 lawyers, 1 minister, and 3 retailers, and we must have at least 1 retailer on the delegation. So we can do this directly and look at the case where we have 1 retailer on the committee, 2 retailers on, or 3 retailers on. So to do that, if we look at 1 retailer, we have 1 retailer on the delegation here, then we have to choose which retailer. So 3 choose 1. And then we also have to choose the remaining members on the committee. So we have to do 5, the remaining people, choose 2. So we pick their retailer, and then we pick the people for the committee, which would give us 30 when you work that out. And then we look at the case where there's 2 retailers on the committee. So we have 3 choose 2 times 5 choose 3. Or sorry, 5 choose 1, my mistake. So 3 retailers choose 2 of them to be on the committee. 5 remaining members choose 1 of them to be on the committee. And in this case here, we have 15 ways in total when you work it all out. And then finally, we have 3 retailers that we want on the committee. So the third case, so 3 choose 3 times 5 choose 0. And we would have a total of 1 different way to pick that. We just pick all 3 retailers. Now, we have 30 ways with 1 retailer, 15 ways with 2 retailers, and 1 way with 3 retailers. So we just add those up for a total of 46 ways to do it. Now, that's the direct method. It's a little bit longer. If you can think of it, the indirect method is a much better methodology for this. So with the indirect method, what we have is we know that we have, what do we have? 8. We have 8 people, and we want to get 3 of them. So that's our total. So that's the total number of ways we can pick for this committee, and that would give us 56 different possibilities. Now we just want to get rid of the case where there's no retailers, and there's only 1 case where there's no retailer. 1 situation. So no retailers. Well, in that case, we're only picking from the 5 people, the 4 lawyers and the 1 minister. So 5 choose 3, and with our 5 choose 3, we have where am I here? 5 choose 3 is 10 ways of no retailers. 56 minus no retailers would give us our 46 ways again. So in both cases you should get the same answer, but the indirect method tends to be a lot quicker. It depends on how many cases you have to work with. You might have to work with a couple of indirect cases too. So you need to take a look at that. You can take away the ones you don't want, or just work on the ones that you do want. Now we have example 2 here as well. So for example 2, you're given a case where you have a bus that has 20 seats on it. 12 of those seats are outside the bus. 8 of those seats are inside the bus. And of the 20 people that are getting on this bus, 5 of them will only go outside and 4 of them will only go inside. So in a case like this, it looks like there's a bunch of situations that could happen, but really, if we put those 5 people on the outside and we put those 4 people on the inside, then we can fill that bus up no problem with the rest of them. So we take our 5 and 4 away from that 20. They're already inside and outside. We now have 11 people left. So we have 11 people left. So 11, choose, let's fill the outside seats first. There's 7 seats remaining once we get those 5 people in there. So 11, choose 5. And then we got to fill in those 4 remaining seats with those 4 remaining people. So 4, choose 4. And when we do that all up, we get a total of 330 combinations. So there's 330 ways of doing this. Now we're going to pass over number 3 for right now, and example number 3, just because it gets really convoluted in that we're probably better off working together on that one. So we're going to move on to example number 4. In example number 4, we have Patty, who's at the mall, going to throw some coins into the wishing well. She has 1 penny, 1 nickel, 1 dime, and 1 quarter. We want to know how many different sums of money she can throw in. So how many ways can she throw 1, 2, 3, or 4 coins in at the same time is what we're asking. Well, this here, how many ways can she throw a penny? She either does or she doesn't. So there's 2 ways of throwing in the penny. How many ways can she throw a nickel in? She either throws a nickel in or she doesn't throw the nickel in. So there's 2 ways. How many ways can she throw a dime in? Well, there's 2 ways. And how many ways can she throw a quarter in? 2 ways. So in each case, she either throws it in or she doesn't throw it in. And this is kind of like flipping coins, heads and tails. You either get heads or tails. So if you flipped all 4 coins and you're looking for heads or tails, there's 2 possibilities, 2 possibilities, 2 possibilities, 2 possibilities for each case. And you just multiply those out. That'll give you the total, but it'll also include the case where these all came up as don't throw them in. So that's one case where nothing would get thrown in. So we need to subtract 1 from that there, and we'll get our final answer. So we have 2 to the power of 4, and so we have 16 minus 1, or 15. So there's 15 different combinations of coins that she could throw into that pool. Now, the next step here, what if she just had 3 more pennies? So that gives her a total of 4 pennies, 1 nickel, 1 dime, 1 quarter. Well, it's still the same idea. How many options does she have for the penny? She throws 1, 2, 3, 4, or 0 pennies. So there are 5 ways of throwing the penny. How many ways for the nickel? Well, there's still only 2 nickels, 2 dimes, and 2 for the quarter, because you only have 1 of each, so you either throw it in or you don't. And again, here, you throw in 1, 2, 3, 4, or you don't throw it in. Again, using our fundamental counting principle here, we're just going to multiply those out. Get rid of that one case where she doesn't throw anything in, and you have 39 different possibilities. That should get you fairly ready for the questions to come. There's a large set of questions there to work on for the next 2 days. On page 52, I want you to do questions number 3 all the way up to question number 19. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's what I mean when I say through to. Couple notes. When you look at question number 6, the word collinear, if you're not sure, means that all 3 points are in a line. So there's no case in number 6 where all 3 points are in a line. Question number 11, and it also affects number 12. A prime number is one that's only divisible by 1 and itself. And the divisor, that is a number that divides equally into another. So 5 is a divisor of 10, because you can divide 10 by 5.